Okay, let me do section 1.2, applications of linear equations. So, in this section, we're going to be going over word problems involving linear equations. And so we're going to read some word problem. From there, we're going to try to use the data to set up an equation and solve it. Be sure that after you have done the problem, you answer the question that was posed and you check that the answer that you've given is reasonable. Page 102, solve each problem. Problem number 11, replacing locks. A locksmith at Papa Lock charges $40 plus $28 for each lock installed. How many locks can be replaced for $236? So first off, when you read a problem, look to see what the question is asking. So it's asking for how many locks. And so let X be the number of locks. So I usually just rapidly read the question and see what the question is asking, and then from there, see what the data is. And so this locksmith charges $40 plus $28. So no matter what, just coming to your house or whatever, wherever, he charges $40 plus an additional $28 for each lock installed. I want to determine how many locks can be replaced for $236. So let me subtract 40 from both sides of my equation. And then let's divide both sides of my equation by 28. Let me get some additional room here. So I can write the answer. Okay, so let's divide both sides of my equation by 28. So x is equal to 7. And so there are 7 locks that can be replaced. Okay. Let me do problem number 17. A wading pool, wading pool dimensions. The area of the triangular swimming pool shown in the illustration is doubled by adding a rectangular wading pool. Find the dimensions of the wading pool. Hint, the area of a triangle is 1/2 base times height. The area of a rectangle is length times width. Okay, so I have here that the area of a triangle, of a rectangle, is length times width, and the area of a triangle is 1/2 base times height. So if I look here, the swimming pool is 16 feet by 20 feet. and the wading pool is X feet by 20 feet. So we want to double the area. And so we want that these two areas are the same so that you've doubled the area. And so I have that 1/2, well, base times height, should equal the length times the width. 20 divided by 2 is 10, times 16 is 160, or 16 divided by 2 is 8, times 20 is 160, however you want to think about it. Divide both sides of the equation by 20, and so x is 8. And so you want to figure out the dimensions of the wading pool. So let's find the dimensions of the wading pool. So the dimensions of the wading pool are 8 feet by 20 feet. And that is the dimensions of my wading pool. Let me do problem number 18. House construction. A builder wants to install a triangular window with the angles shown in the illustration. What angles will he have to cut to make the window fit? Hint, the sum of the angles of a triangle equals 180. Okay, and so we want that the sum of these angles should equal 180. Combine like terms. 1x plus 1x plus 1x is 3x. 30 plus 30 is 60. Subtract 60 from both sides of my equation. Divide both sides of my equation by 3. And so the angles here, well, you have to plug in x. And so if you plug in x, well, this is just 40 degrees, but x, well, 40 plus 30 is 70. And so the angles are going to be 70 degrees, 40 degrees, and 70 degrees. Those are the angles for my triangle. Let me do problem number 20. Depth of a water trough. The trough in the illustration has a cross-sectional area of 54 square inches. Find the depth D of the trough. Hint, area of a trapezoid is 1/2 B1 plus B2. Okay, so let's do this. Obviously needs a little bit more space here. And so the area of a trapezoid is, well, say this is B1 and B2, and this is H. The area is 1/2 B1 plus B2 times H. And so I want that this has an area of 54. Oh, and I guess I should draw what they're telling us. And so this has a 28 in D. So this is 20, 8, and this is D, and the area is 54 square inches. And so the area is 1/2 the sum of the bases times the height. That's a 12. I wrote the wrong thing. That's a 12. 12 plus 8 gives me 20. 20 divided by 2 is 10. And so let me divide both sides of my equation by 10. And so my depth is 5.4 inches. And I guess I'll probably leave it as 5.4. Okay, so let me do problem number 24. Investment problems. A woman invests $37,000, part at 8%, and the rest at 9.5% annual interest. If the 9.5% interest provides $452.50 more than the 8% investment, how much is invested at each rate? So I should write everything in terms of the 8% investment, and so let X equal the amount of money in dollars invested at 8%. Okay, so then we have that the amount invested at 9.5%, which is the total amount that they invested, was $37,000. And well, it's what he didn't invest in the 8% is how much he invested in the 9.5%. And this should be $452.50 more than what he invested at 8%. Let me multiply the 0.095 inside the parentheses. And so I get 3,515 minus 0.095x is equal to 452.50 plus 0.08x. Let me subtract $452.50 from both sides, and let me add 0.095x to both sides of my equation. Okay, and so if I do that, well, the 0.095x's cancel, and so I get $3,062.50 is equal to, well, the $452.50 cancel. So if you add these together, you get 0.175x. Divide both sides of your equation by 0.17, 0.175, And so you get that X is equal to 17,500. And so the remaining amount, 37,000 minus the 17,500 is 19,500. So she should invest $17,500 at the 8.5% investment in the 8.5% investment and $19,500 in the 9% investment. Oh, I'm sorry. It's 8%, the other's 9.5%. So at the 8% interest and at the 9.5% interest. And that is your answer. Okay, let me do problem number 37. Filling swimming pools. An empty swimming pool can be filled in 10 hours. When full, the pool can be drained in 19 hours. How long will it take to fill the empty pool if the drain is left open? So it takes 10 hours to fill it. So 1/10 of it can be filled per hour. You remove the filling because you're draining. Well, 1/19 of it per hour because it takes 19 hours to drain the pool completely. And suppose that it takes, with these two combined processes, X hours to fill the pool. And so 1/X of it is filled per hour. Let me multiply both sides of my equation by the least common denominator, which is 190x. And so I get 19x minus 10x is equal to 190. So subtract, so you get 9x is 190. I might have enough room, or at least close to enough room. Put this at the bottom. Divide both sides of my equation by 9. So x is equal to 190 divided by 9. And so let's write this in hours. Well, 190 divided by 9 is 21.111. And so there are 60 minutes in an hour. And so let's multiply the 0.111 times 60. And so you get 0.06. 0.8 multiply by 60, and so you get 40. So 21 hours, 6 minutes, and 40 seconds. And that's how long it takes you. So this is in hours. Let me do problem number 52. Preparing medicine. A doctor prescribes an ointment that is 2% hydrocortisone, so I have that this is 2% hydrocortisone. The pharmacist has 1% and 5% hydrocortisone. How much of each should the pharmacist use to make a 1 ounce tube? Let's say that, let's say X ounces of 1%, then, well, since they must add up to 1, then this has to be 1 minus X ounces. And so, by conservation of the hydrocortisone, we have, well, 1% of X plus 5% of 1 minus X must equal 2% of 1. So let's simplify this. Let me multiply the 0.05 inside the parentheses. So I get 0.01x plus 0.05 minus 0.05x equals 0.02. Combine like terms, and so I get 0.05 minus 0.04x equals 0.02. Subtract 0.05 from both sides of your equation. So 0.054x is equal to a negative 0.03. Divide both sides of your equation by a negative 0.04. And so x is equal to 3/4, so 0.75. And so that says that well, 1 minus x, therefore, is 0.25. And so, move this down just a little bit. Okay. Good. And so I have x is 0.75, and so 0.75 ounces of the 1% hydrocortisone and 0.25 ounces of the 5% hydrocortisone. And that is your answer. Actually, so it doesn't look like it's too high. And so that's your answer. Let me do problem number 64. Architecture. The Norman window with dimensions as shown is a rectangle topped by a semicircle. If the area of the window is 68.2 square feet, find its height h. And so here is my Norman window. And so it is a rectangle. And let's just recall that the area of a rectangle is length times width. In this case, the length here is 6 feet. And the height here, well, I'm going to have to explain this, is, well, note, if this is 6 feet, then the diameter of the semicircle is 6 feet. Therefore, its radius is 3 feet. And so this height here is 3 feet. And so if this is h, so if this distance here is h, and this is 3, then this must be h minus 3 feet. And so that's just h minus 3. Next, the area of a circle of radius r is pi r squared. And so, if you have a semicircle, of radius 3, then its area is 1/2 of the area of a circle, so 1/2 pi r squared. Okay. And so the sum of these must be 68.2. So the area here is length times width. And so 6 times h minus 3 plus the area of this semicircle, 1/2 pi times 3 squared. That must equal 68.2. And so, let me multiply the 6 inside the parentheses. So I have 6h minus 18 is equal to plus 3 squared is 9, halves pi is equal to 68.2. Let me add 18 to both sides of my equation. Let me subtract 9 halves pi from both sides of my equations. And so if I do that, I get 6h is equal to, oh, I'm adding. I was going to say 50.2 is equal to 86.2 minus 4.5 pi. 9 halves is just 4.5. And so let's divide both sides of my equation by 6. So h is equal to 86.2 minus 4.5 pi divided by 6. Let's move this down just a little bit. And this will be feet. And that is the height h of this Norman window. And so that finishes off this section.